In continuing our learning about functions, we're going to learn how to write a function rule today. Okay, here's an example of a function table, and we're going to have to write the rule for this function. So in order to write the rule, you want to check to see what kind of a function it is. So we're going to just do a quick check. If you remember, we went through how to tell if this is a linear function or not. And when we check this, we can kind of see pretty quickly that this is always going to be a +1 on this side, right? Our common difference over here. This is going to be a +6, and a +6. So we can see this is in fact linear. So once we know it's a linear function, what that tells us is that f of x is going to be equal to something x, and then it's going to be plus or minus something over here. So what we want to do is we want to see if we could figure it out. Now, the easiest way to do this with a linear function is if there's a 0 in your x column, okay, which clearly we have a 0 in our x column, okay, what that tells you is the number directly across from it in the f of x, that number 2, is going to be the tail of our function. What that means is it goes at the end. So now we know that we have +2. Okay, and then the next procedure we're going to do is we're going to see if we can sort of undo it like we're solving an equation. So because we have to add 2 to the f of x, we're going to subtract 2 from each of these other numbers. So what that does now is that gives us a 6, a 12, and an 18. So once we've gotten rid of the tail of the function, if we now look directly across from the 1 in our new column, that number that you see there is the coefficient of x. So this function is f of x equals 6x plus 2. Now again, this only works when you have a 0 and a 1, okay? Well, the 0 thing works every time you have a 0, you're going to be able to see the tail of the function, okay? And then if you also have a 1, if you undo the tail of the function, you're going to be able to get to the coefficient of the function. Let's try another one. All right, so here's another function. And again, our x would be here, our f of x would be here. And we're going to look to see again, is this a linear function? And again, hopefully you can kind of see that this is going down by 1, right? And that continues. This is going down by 6, and that continues. So again, we do have a linear function. So if you remember from the last one we just did, that means that we have f of x is going to be equal to something times x, and then we'll have a tail of our function. The number across from the 0 is our tail. And if we were to undo that tail to these other numbers, and again, you don't have to worry about undoing it from the 0, because if you undo it from the 0, you're going to get 0. So we have to add 11 to each of these numbers. Now, if we look across from the 1, we could see in our new column, we have a 6. So this function is going to be 6x minus 11. Okay, let's do one more this time, not quite so simple. Okay, so this time when we look at our function table, you can see that this side is an increase of 1, right? Pretty consistent, we like that. When we get to this side, this increases by 3, this increases by 9, this increases by 15. So we're not linear. So let's see, how do we do this if we're not linear? Well, we still know that we're going to have f of x equals, right? Something, and then there's going to be an x somewhere. And we can try the same thing that we did before with the 0. The number across from the 0 is a -2. So let's say that our tail of our function is a -2. Let's get rid of this. Okay. And now what we're going to do is we're going to undo subtracting 2. So we'll add 2 to each of these. And that's going to now give us a 3, a 12, and a 27. Okay. Again, look across from the 1. Our new column across from the 1. It's going to give us a 3. So let's say that our 3 is here. Okay. Again, this is what we're trying. And we're going to see how it works. Then the next thing that you want to do is you want to pick the biggest number. Okay, I'm looking for the largest number in my new f of x column. which is going to be 27. Okay? And what I'm going to do with that is I'm going to divide that by 3, because 3 is our coefficient. So if I divide 27 by 3, that's going to give us 9. Then the question you have to ask yourself is, that number in the x column, to what power would give me 9? And hopefully you realize that 3 to the second power is going to give you 9. So that would mean that my x actually has an exponent of 2. Now, to make sure that that's right, go to one of the other numbers, like we'll go to 12, and we'll divide that by 3, again, because 3 is the coefficient, and we get 4. And then 2 to what power is 4, and that should be the same power as you got when you did x to what power is 9, or 3 to what power is 9. All right, so hopefully you gained a little bit of knowledge here.